Assalamualaikum warahmatullahi wabarakatuh. My name is Hidayah binti ZAINON and I am supervised by Madam BALKIAH MOKTAR. So now I will present my proposal with topic feasible features for heart attack prediction using score and correlation based. This topic have 3 chapters. So now let's move to chapter 1. For background of the study, heart attacks and cardiovascular disease are common in Malaysia, leading to significant public health concern. Ischemic heart disease, which is heart attack, is the leading cause of death in Malaysia, accounting for 70% of all death in 2020 by Statistics on Causes of Death Malaysia 2021. Ischemia is a condition where blood flow and oxygen supply to a part of the body are restricted or reduced, causing damage or death to heart muscle. The most common causes of heart attack is coronary artery disease, which is the most common type of heart disease. Risk factor for heart attack including smoking, high blood pressure, high cholesterol, diabetes, and obesity. For problem statement, several risk factors heart attack including high blood pressure, high cholesterol, diabetes, smoking, and obesity, which is like I mentioned before. People with no risk factors can have a heart attack. Several methods for predicting heart attack risk available in literatures. This research intended to be filling the gap by incorporating the feature selection technique. Could then be used to develop more accurate heart attack prediction model with less time consuming. For objective of the study is to identify the most important features for heart attack prediction by using feature scoring ranking. Next, to apply classifier on selected features. After that, to compare the performance of the classifier before and after applying the feature selection method. Next, scope and limitation of the study. I get this dataset from Kaggle dataset, Heart Attack Risk Prediction Dataset by Soras Banerjee 2023. The collection of 8,763 patients record from around the world includes a vital binary classification characteristic indicating heart attack risk, but for this research only focus on patient records from Asia and gathered data from 2,544 cases. This study focused on selecting the most informative and discriminative features while discarding irrelevant or redundant ones. Lifestyle factors, previous heart issues, drug use, cholesterol, income, and geographical factors are considered. For significance of the study is to develop a more efficient and accurate heart attack prediction model using feature selection technique and to identify individuals at high risk for their first heart attack experience by selecting the most important features. Chapter 2, Literature Review. Firstly is the history of heart attack in the world. The history of heart attacks or myocardial infarction traces back to 17th century with the first documented case by English physician Thomas Sydenham. Progress is understanding linked heart attacks to coronary artery blockages in the 18th and 16th century. In the 20th century, risk factors like high blood pressure, high cholesterol, smoking, obesity, and inactivity were identified. However, heart disease remains a significant global health issue, with over 17.9 million annual deaths worldwide, according to WHO, and over 60,000 in the US alone as per CDC. From recent research, indicates a rising concern for heart disease is younger population, especially women aged 35 until 54 since 1960. Despite medical advancements, addressing root causes and supporting affected individuals and family is crucial. Feature selection process. Feature selection is a crucial step in machine learning that reduces the number of input variables by eliminating irrelevant or unnecessary data. 4 main categories of feature selection technique include unsupervised, supervised, which is wrapper, filter, and embedded method, hybrid, and supervised, further divided into wrapper, filter, and embedded method. Supervised methods use the target variable to identify variables that enhance model performance, while unsupervised methods do not consider the target variable. Wrapper methods select feature subsets based on performance metrics. Filter method use statistical measure to assess variable dependence. Invented method incorporate feature selection directly into the learning progress. And then feature selection technique with machine learning, which is the article that are related with my topic. Data and Java 2018 use feature selection implementation, ensemble technique, algorithm for boosting. The dataset get from Cleveland heart disease dataset, and the best method ensemble technique, bagging and boosting. Based on the research by Takchi 2018 to figure out which machine learning method and feature selection program can best predict heart attack. With an accuracy of 84.81%, the support vector machine (SVM) algorithm with the linear kernel and the feature selection algorithm by the relief method got the best result. Chandra Reddy et al. 2019 suggested using machine learning to determine the probability of someone getting heart disease. This could help bring down the cost of detection. The random forest (RF) algorithm works well for this job because it is accurate 19 until 95% of the time. Sendan et al. 2021 used feature selection, feature engineering, exploratory data analysis (EDA) for do testing to Cleveland and heart failure dataset and get SVM as a best method with accuracy with percentage 93.3%. Lastly, Chapter 3, Methodology. Dataset sources obtained from Kaggle. It is include comprehensive features on heart health and lifestyle choice. Patient-specific information, which is age, gender, cholesterol level, blood pressure, heart rate, and indicators like diabetes, family history, smoking, obesity, and alcohol consumption. Additional factors include lifestyle, exercise, dietary habits, stress, sedentary hours, and medical factors. Previous heart problem, medication usage, triglyceride levels. Geographical and income attributes include country, continent, hemisphere, and income. Dataset overview initially had 8,763 records globally with a vital binary classification features indicating heart attack risk, but this research only focused to 2,544 patient records, specially focusing on Asian patients. Next is data pre-processing for classification. This is the example from all dataset for diagnosing heart attack features with metrics. Then, the visualization for numerical features. And the summary statistic for numerical features which have minimum, maximum, mean, and standard deviation. Feature selection. For this research, I use filter method. Filter method analyzes feature relevance independently of the chosen machine learning technique. This method often employs statistics like correlation and mutual information to rank features. The goal is to assess which attributes exhibit high predictive potential when applied to different algorithms. After that, they have score and correlation in filter methods. Score-based method utilize Fisher score to rank variables in descending order, offering a widely used supervised feature selection method under filter methods. Correlation-based method measure linear relationship between variables, predicting one variable from another. Additionally, for exploring correlation attributes involving analyzing relationship between variables to understand how change in one may relate to change in another. Correlation is a statistical measure ranking from -1 to 1, which is 1 perfect positive correlation, -1 perfect negative correlation, and 0 no linear correlation between the variables. Then, this is the example of formula calculating the correlation coefficient and correlation-based feature selection. For classification model selection, I use 5 models to compare the results, which is J48, Logistic Model 3, LMT, Random Forest, RF, Random Tree, RT, and REP3. In model evaluation, I use splitting strategy, which is 17-13 strategy. This is the research flowchart. Firstly, do the data pre-processing, then apply feature selection, after that applying classification model, and lastly, see the performance model evaluation. That's all from me. Thank you.